Hello everybody. So our topic today, water management. So where should we start? Well, let's start with some of the easier stuff. So water is extremely vital to plants. Trees, they absorb water and minerals as a solution, so it's dissolved in water, the minerals from the soil. For a large tree, it can absorb hundreds of gallons of water in a day. And then, maybe I'm hoping that the next question you have is, why does it absorb so much water throughout the day? And it's because up to 95% of that water may be transpired. So, transpired is just a way of saying that the tree takes the water up, uses it, and then gives it back off into the water cycle after being used by the tree. If you don't have sufficient soil moisture for your trees, so your tree's going to become dehydrated, and the trees spend most of their time trying to just keep cool. That's what trees really do, and that's where a lot of the use of water comes in. It is used for minerals and to bring up the minerals, because the minerals are in solution in order for them to be taken up, so they need water as well for that. But it's really crucial to understand that trees mostly use water to just avoid dehydration and to just keep themselves hydrated. If they don't have sufficient soil moisture, trees will stop growing. And then you can also just get different versions of plant decline, whether that's wilt or the leaves looking terrible in all sorts of different ways, or mineral deficiencies, those sorts of things. It could be a combination of things. Too much water, of course, is also bad as well. So it's really important to make sure that wherever your root zone is for your tree, that you have the adequate amount of water in that root zone. So in California, sometimes irrigation is going to be definitely a necessity, because you've just got drier areas where water is it's just going to be a limiting factor. You really want to use the appropriate amounts at the appropriate times. And like we just kind of mentioned before, overwatering is bad, underwatering is bad. Proper amount of watering is really the only thing that's acceptable. Good water management programs need to consider the water requirements for different tree species, different soil conditions, different environments, different irrigation systems and scheduling, different water conservation practices, and different types of drainage. All those things play into how we manage our water, and all of those things are important to us, and we should take a look at all of them, which is what we're about to do. Another thing to just kind of think about is the idea that environmental plant stress is going to affect plant health. So most of the plant problems that we run into in the urban forestry setting are pretty much down to probably a lack of water, for the most part. You've got if you're seeing something like this picture here, and you're trying to basically solve the problem. The first thing to think about is what does the irrigation look like, and what is the water stress looking like. And a quick example of that, somebody had called me up as an arborist and asked me to come look at their tree, and they were telling me about the irrigation system that they have set up for their tree and what it looks like and all the stuff that they did. And then I get to the house, and the whole front yard, all the grass is dead. And I walked right up, I looked at what was going on, and I was like, I think we have a water issue, because the whole yard is dead, and then they're worried about the trees. It's like, well, I think I know what the problem is. So let's kind of talk about water, and let's try and understand soil water, because that's the water that our tree is getting, and then we'll take it from there. So the first thing we're going to start off with is hygroscopic water. So if you look at our little picture here, you see it says these are the soil particles in our solution, and then you see right here it says hygroscopic water is this circle around the outside here. So it's hygroscopic water basically forms a film on soil particles, and it's held, this type of water is held by the soil particles through the process of adhesion, and it's basically, it binds onto the soil particles, and it's actually not available to the plants. It's there specifically for the soil particles, and it's bound onto them, and so it's not available for plants, but it is water within the soil. You got capillary water. Now this is what we usually think of as available water. So it's water that's going to remain in the soil after gravitational water has drained out. That's the next one we'll talk about, is gravitational water. And it is subject to the laws of capillary movement, and that it's in the form of a film around the soil grain. So we can see this same graphic from before. There's our hygroscopic water there, and then here's our capillary water that's forming this film kind of in between the soil grains. And then right here, that's going to be the third one we talk about, which is either an air pocket or it could be gravitational water working its way down through the soil as well. So gravitational water, water that drains freely from the soil, usually before 3 days after irrigation. So sometime before 3 days after irrigation, gravitational water will have worked its way through the soil. Why 3 days? Because after that, we don't really consider it gravitational water, because we're just talking about this stuff that basically will come into the soil, move its way down through the soil, and then, kind of, it doesn't stick around sort of a thing, because we're really interested when we talk about soil water with what is going to stick around. Gravitational water is free water that moves through the soil due to the force of gravity. So we talked about hygroscopic, forming the film around the soil particles. We talked about capillary water, getting which is held in the micropores, getting held as that film in between the soil grains. And gravitational water is just draining right through. So it's free water that's moving through the soil due to the force of gravity. Gravitational water is what's going to be found in the macropores. So we have our macropores and our micropores in our soil. Capillary water is in the micropores. Gravitational water is moving its way through the macropores. It moves rapidly out of well-drained soils. Think about sand at the beach. And gravitational water just in and down and through and gone. And it's not really available to plants. Capillary waters are a really important one when we're talking about plants. See right here, available water. Plant roots can absorb this. Gravitational water is draining right through, and then hygroscopic it's so strongly adhered to the soil particles that it's not available to plants. Now, if you say to yourself, well, what's the point of like the hygroscopic water as opposed to capillary? Because capillary is available for the plant roots, and gravitational just kind of drains right through. So gravitational water drains right through, but that stuff ends up in the aquifer, so that's kind of a good thing for us because it ends up as groundwater. Capillary water, available for the plant roots, fantastic. Hygroscopic water, we need to make sure that that our pores stay open on our soil, and our soil is healthy, and our soil is happy, so it's got its water. So it's almost like there's a whole system where the soil gets its water, the plants gets its water, we can get our water. Works out actually pretty nice. Let's take a look, another way to look at it again. So hygroscopic, capillary, and gravitational water. So you can see right here, we've got some hygroscopic water. See the black line around it. We've got some hygroscopic water. It's not available for plants. Here we go. We've got our capillary water. We've got some available for plants now. We hit field capacity, which we'll talk about. We hit saturation, and now we got too much, so we're going to get gravitational water where it forces its way down through the soil. So let's talk about field capacity. So when we're talking about field capacity, we're talking about the water holding capacity. which is the total amount of water held by a soil after drainage occurs. So the water holding capacity will vary with your soil texture, whether it's mostly sand, silt, or clay. The idea behind a loam soil is the idea that it's got that perfect mixture of all of those, so it's got the best of the water holding capacity. Well, clay has the best water holding capacity, but it holds it so much it doesn't actually go through the soil. That's why loam is the best in terms of, because it's got water holding capacity, but then also allows the water to move through the soil. So sandy soils, if you're planting trees on sandy soils, more than likely you're going to have a need for irrigation much more frequently than clay soils would. So just going back here for a second, that idea of field capacity, we hit field capacity, so we've got enough water where we're just kind of, we're soaked enough and we're good, and we have all the water we need. Well, because we have all the water we need, now that's going to create more gravitational water, because that water is just going to move through the soil or create surface runoff on the top because we don't have any use for it. We're all filled up. So water movement in the soil. Water is going to move downward, laterally, and sometimes actually upwards in the soil. Most of the time downward and laterally, but it can move upwards in the soil as well. We've used a couple terms already, but we'll just kind of go over them again. Infiltration. Infiltration is describing water movement downwards through the soil. Percolation describes water movement within the soil. In response to gravity, water moves downward faster and more extensively than it will go sideways. So it's easier for water to move down because of gravity, a little harder for water to go this way, but it still can do it. And both infiltration and percolation are going to be affected by soil textures. Clay soils, much lower infiltration rates than sandy soils. Clay soils, think of, that's the reason you see like a lake, there's a lot of clay underneath. Sandy soils, think about the beach, water goes in, water goes down, water goes out. So our look at our infiltration versus percolation. So infiltration, downward movement of water through the surface of the soil. Percolation, the process of filtering infiltrated water through soil particles and porous materials. So infiltration is just the water going into the soil. Percolation is now where does that water go and where does it move to and how does it get in through the soil particles. Infiltration is going to occur closer to the soil surface and near the plant's root zones. Percolation in between the unsaturated and the saturated zone of the soil. Why do we need infiltration? It replenishes our soil moisture deficiency. Why do we need percolation? It replenishes underground aquifers. So we need that water to make its way all the way through, some of that gravitational water that's going to percolate all the way down through and get down through the soil and into the aquifer. So here's a look, just a quick look at the hydrologic cycle or the water cycle. We get precipitation coming in. Maybe we get some interception here, so that water doesn't make it into the soil. That gets stuck on the leaves, that sort of a thing. So we'll get some other water coming in. There's our infiltration. Our water starts making its way through the roots or just into the soil. We get a little surface runoff, the stuff that doesn't infiltrate in. Some of that water then becomes through flow, where it just kind of works its way through the soil and maybe hits where some sort of a low point where we're collecting water. We get our percolation, where some of that infiltration keeps working its way down, and eventually we can get it into, once it gets below the water table, now it's into our aquifer and becomes, sits there and becomes part of our groundwater flow and where we can store it. So how about trees and water? Let me move myself out of the way real quick there so you can read that. So, with trees and water, the amount of water needed by plants is going to vary by size and species of the plant. That shouldn't be surprising at all. But it's also going to vary on soil conditions, air temperature, humidity, light levels, and wind movement. All of those things are going to affect it. Transpiration, you've heard me use that term before during this lecture. Transpiration is the water lost from the leaves, and that's actually controlled by the leaf stomata. So the little pores on the leaf that we've talked about before, they open and close as responses to the environment, and so they're going to basically open up to take in CO2 and throw out oxygen. But when they're throwing out oxygen, which is great for us, we're also having some of that transpiration and some of that water loss, where the water goes back into the hydrologic cycle. When transpirational water losses exceeds the plant's ability to take up water from the soil, so when you're losing more water than you are getting from the soil, your plant is going to wilt. And that just kind of makes sense. Now I'll go back up here to the top right, get out of the way. If you have an extended period of water deficit or drought, which we're very used to that term here in California, the plants are going to respond. They're either going to wilt, they're going to show scorching, which is the leaves just kind of look burned. They have like darker colors on them. Some plants will just kind of drop leaves and basically start kind of retreating to the main trunk. So you'll see like the parts, the twigs first won't have leaves, and then the main branches, and it'll just keep dropping leaves until it's the trees kind of hit a spot where it's like, okay, I can support this amount of leaves, and I'll just kind of retreat in until I get to an amount that actually works for me. And then it could also either increase the production of absorbing roots, so the fine roots kind of in the upper part of the soil. It'll just put more of them out there, and then just kind of stop doing canopy growth. So the idea is just like, I'm going to put more effort into the underground growing part, because that's important, because I need to go get more water. So you can have severe drought periods, and if you have severe drought periods, we're talking about extensive root loss, we're talking about leaf abscission, twig dieback, plant death. Basically, the tree is just going to try and do things like wilting, scorching, dropping its leaves to avoid death, but then eventually it's just going to keep piling on and piling on until the tree gives up. So if you've got water stress that's prolonged and the plant can no longer recover, that is what's called the permanent wilting point, meaning that is the point of no return. Once the plant gets there, it's done. You can water it as much as you want, give it, fertilize it, do whatever you want. It's not coming back. So here's a look at it when we're saturated. Sometimes that's a good thing. Sometimes that could be a little bit too much. But if we're saturated and we've got too much water, we're going to get that gravitational water coming out. So we're getting gravity water draining, and that's unavailable water to the plant. However, if it's out there in the environment, good for us. It's going to go down into the aquifer, and we'll have more groundwater available. If we're at field capacity, we're good. We've got plenty of water. We're fantastic. We've got some readily available water, but now we've got evaporation happening. We've got available water. We're still good. Now we're getting the wilting point. We're not and it's obvious too. Like, we're not sitting up here like we were before. Now we're drooping, and we're still giving up water, and we don't have a lot of available water coming in. And now we've hit permanent wilting point, and we're down here, and we have unavailable water, and it doesn't matter what we do to this thing at this point in time. It's not coming back. And then ultimately, we die. Note, permanent wilting point and death of the plant are not the same. Permanent wilting point is that point where there's no return, but you're basically just kind of counting down the days till the plant gives up at that point. So, not much I can do with getting myself out of the way of that picture over there, but you can see the majority of it. So, when we're talking about plants and water, small leaves are going to provide a reduced surface area in which water can escape through transpiration, so that's kind of a good thing. If your plant has a waxy outer layer, a cuticle, may further limit moisture loss to the air because the waxy layer basically holds water onto the surface, which is good. If you have a hairy leaf or a leaf that has tiny leaf hairs, which we call pubescence, that's also going to prevent water loss because it basically provides insulation and kind of traps the moist air and traps the water on the leaf surface and then just kind of keeps it there. Another thing that plants, another adaptation that they do is sunken stomata. So they're basically protected by a small pocket of stagnant air, which is going to collect in the little depression that the opening creates, and so that air is going to kind of hold water as well. And so some examples of trees that have done this are olive, and then this one that I've put on the right here, which is salt cedar. And then there's also tamarisk as well. And I have a personal connection to tamarisk and really understand what they can do with water because I worked for the BLM for a little bit and did some tamarisk removal down outside of Los Banos off of I-5, where there was an area that it was a wetland area, and all there was nothing but tamarisk trees. It looks a lot like this, and these trees just suck up water and suck up water and suck up water till there's just nothing left in the area. You can kind of see it with this salt cedar that does the same thing, where it's just this dried out area behind it because it should have water, and then it just kind of sucks up all that water. And so took out a bunch of trees, and I'm hoping that if I were to figure out where that was, because it was like 20 years ago, so I honestly do not remember where it was, but if I go back there, I'm kind of hoping that I'll see a tiny little wetland as opposed to just a bunch more tamarisk trees sitting there. That's what I'm really hoping for, especially because we also put in fencing, so hopefully that whether we were moving cattle in there or whatever, we did something to get rid of that thing forever. That's my hope. Roots. We've talked about them already a couple times. They are super important in this whole thing. Why? Because they're the ones going into the ground. Well, where's all the water? The water's in the ground. Well, therefore, the roots are going to be pretty important. Some plants are going to have extensive root systems, especially if they're in arid regions, because they're going to just have to spread farther and farther and farther to try and get to the water. Some plants are going to develop deep roots, a big huge taproot. But really, the whole idea with the roots is they want to get to groundwater. They want to have the biggest and best chance for survival, so they're just going to spread out as far as they have to. Here's just a kind of a quick summary of some of the stuff we've talked about, right? 90% of the tree's water, we think it's probably closer to 95%, is eventually dispersed and released through the leaf stomata through the process of transpiration. Nutrients feed the tree through the process of photosynthesis. We know that part already. Water is going to enter the roots, mostly through osmosis, and the nutrients are going to travel upward through the bark's xylem using that capillary action. They're going to pull water right on up, and that's going to get us our minerals to our tree. Now, because we were just specifically talking about roots, what do we mean? Well, if we're heavy on the idea of we live in an area where there's going to be precipitation, and we're going to get a lot of water coming in on the surface, we're going to spend most of our time growing our roots laterally and really trying to get a lot of fine absorbing roots out here, and basically where we can cover as much land and much area as we can, because we know it's going to be tip, 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 drip, 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 all over the place. Now, if we're not really planning on precipitation being the thing, and we're really just looking for that subsurface flow or groundwater or that sort of a thing, we're going to have our water maybe a more sinker roots, where they're going to go down, or maybe even a large taproot, where they're going to go down and really, usually your sinker roots and your tap roots are all about structure and anchoring in the tree. But, in this case, if that's where the water is, then, you got to go find the water. Another look, kind of trying to put this whole thing together. So, water cycle, we get some rainfall. We're giving up, we've got water evaporating out. We're using some of the water, so that water's transpiring out. So sometimes you'll hear the term evapotranspiration. That's just a fancy term that means it's just combining the evaporation and the transpiration. If we have our hill like we do here, maybe we get some runoff happening. Here's our water table, and just if we're not comfortable with the term water table, it just means the top of the groundwater. So what we're seeing here is all of this area down here below there is just all water and water storage. And so, here's our root zones for our trees. We'll get some infiltration. We'll get some percolation, getting water down to the water table. So our root uptake is going to be happening up here. And whatever infiltration we can get, we're going to try and grab as much water as we can before that water ends up working its way down. Move myself out of the way here. So, irrigation, because we said that's going to be important, and it is pretty crucial for a lot of areas, especially your arid areas. There are definitely tree species that are adapted to drought-like conditions, and there are definitely tree species that aren't adapted to drought-like conditions. And if you're, first disclaimer, plant trees in areas that make sense. If you're in a really arid area, like you live in Palm Desert, plant trees that are going to be adapted to drought-like conditions. But if you have to plant trees that are not adapted to drought-like conditions, then you're going to need irrigation. Your irrigation requirements are going to vary with whatever tree species, however big the trees are, and the environmental conditions that you have there. What are we talking about in terms of environmental conditions? Soil texture and structure, the sun exposure, how much wind you get, and the humidity. All those things are going to affect how much water you need. Especially because, remember, the whole thing about water and why the trees need water is because they're going to use it to just try and keep cool. So the amount of sun you're getting and the amount of wind that's hitting the tree and the humidity, all those things are going to affect basically how much the tree is sweating. Your need for irrigation can be reduced or even eliminated if you've got proper planting and plant selection and you're able to match the environmental conditions with the tree's water requirements. What does that mean? Plant drought acceptable trees in areas where you're going to have drought. Plant trees that like a lot of moisture. If you're in an area that's going to be like a floodplain where it's going to get a lot of moisture, just match up site and species. Match them up. Put the right species in the right sites. Super important. Slide back up here. Boom. Infrequent deep soakings can encourage the development of a deeper root system and more drought-tolerant trees if that's something that you're looking for. If you're trying to kind of create similar conditions. Some soils, especially ones high in clay, can be improved by being allowed to dry out between irrigations. It's the natural shrink swelling of that soil can improve the soil structure and the infiltration rate. And then in the inverse of that, frequent shallow irrigation can compact your soil and reduce the infiltration rate. Can really depends on your area, site, and species. Specifically, what is it that you got planted here, and what does it like, and what should be planted here? When do we irrigate? This one is that just annoys me to no end to see this. It's often best to irrigate in the evening through the morning hours, especially for sprinkler systems. Why? Less water is lost through evaporation and more water is able to infiltrate the soil. And it is a huge difference. I see people out here in Bakersfield constantly irrigating their lawns at because they don't know the difference at whatever, 4 o'clock in the afternoon, 3 o'clock in the afternoon, 5 o'clock in the afternoon. I mean, they're probably getting about 20% of the water that they should be getting, and maybe even less than that. And if you think about how much water they're using to do it, oh, well, it's only, 10 minutes or whatever. Yeah, it's a lot of water. And especially if you think about the fact you're only getting 20% of it. So when do I water my lawn? My lawn gets watered at 5 o'clock in the morning. That's usually when I've got it set for. And the reason I choose 5 o'clock is then I'm usually waking up at 6, so at least by the time the sprinklers have worked their way all the way through, I can still kind of, as I get up, I can figure out, is anything going wrong? Is all of a sudden do I see oh, my lawn is soaked here. I've got a problem with a head somewhere that I've got to go figure out. You also, depending on your areas, we don't necessarily have them here in the city of Bakersfield anymore, but many municipalities will have water use regulations that say when you're supposed to use water. Some situations, if you've got foliar diseases that are a problem, you really don't want to use irrigation systems that are going to keep moisture around the leaves for an extended period of time, because you're just inviting in pathogens, and you don't want to do that either. Should go without saying, but we'll say it anyways. Water should be distributed uniformly to as much of the root system as possible. The trees spread all those roots out there. We kind of just want to give everybody a little bit and make sure everybody's happy. Now, if only part of the root system can be watered, if you have hardscape covering the soil surface, what does that mean? If you ever walked in the city, because we're talking about urban forest, you walked in the city and you just see a tree planted in the middle of concrete, and there's just a little circle and then a little bit of soil exposed, and then there's your tree. Well, that root system is going way farther than that little circle. Just usually think, if there's no competition between trees, you usually think 2 to 3 times the canopy. So, you see that little circle, and that's where the canopy is, but the roots are probably 2 to 3 times the size or the distance away from that. And so if you can only water the part of it in that case, then, that's still better than not doing anything. So do your best to irrigate that one part and hope that it can, that your soil isn't compacted and all sorts of other issues and can spread it out. But if the trees start to die, you're probably going to figure out real easily what the problem is. Efforts should also be made to keep the root collar dry. So that's the lower trunk is the root collar. So just think about, when we say the root collar, think about the taper of the tree. So when the tree is kind of fatter at the bottom, and then when it tapers up, that fatter part, that's what we call the root collar. You want to keep that dry between irrigations. So obviously it'll get wet when you're irrigating, but then you want it to be wet and then dry out, and then get wet and dry out. And the reason you want that is because you don't want to get soil-borne pathogens, because if you stay wet, think about kind of like moldy and mildewy situations, like in a bathroom, if things are just wet constantly and it's humid and things just kind of get gross in your bathroom. Same thing with the root collar. It'll just kind of get gross, and that's just a way for pathogens to come in, and we are not trying to hurt our trees in any way. So just kind of a infographic, how to water your trees, what works, right? Irrigation systems and sprinkler heads are not an effective way to water trees. Mulch is great, and some of the other types of systems work really well. This kind of gives you an idea how much water is going to cost, at least in Salt Lake City. What are your good water methods? Soaker hose, hand watering, 5-gallon bucket, drip irrigation. We'll talk about drip irrigation here in a little bit, and just, some instructions if you kind of want some instructions on how to do that. So, interestingly enough, with the infographic I just posted there, sprinkler systems aren't that effective. What's most common? Sprinkler systems. Why? Because they're already there for the grass. The trees are there, so yeah, it'll just work for everything. Not really, but we understand that that's the way people see it, and we're just going to have to do our best to work our way around it. Both sprinklers and drip systems have advantages and disadvantages. The big thing is it's just got to be well designed, and it's got to be maintained, and it's got to apply water effectively and efficiently and enough water. So you've got to really consider the valving, the pipe sizing, the head selection, all those sorts of things, as well as monitor the system to really make sure you're getting what you need for your trees. So specifically with sprinklers, they are really good at applying water uniformly across the root zone of the tree because they get water everywhere. It's really important to make sure that they are applying the right amount of water, because if you get too much water in too small of a time, you get runoff, you get erosion, you start getting like rills and channels and little things forming in the soil where the water just starts going off, and then that'll lead to more problems eventually. So you really want to make sure you got the right head size and you got your timing right, and you're making sure that you get enough water on your trees, but not too much, especially if you start getting it to where you just start getting the crusting happening on the top of the soil, and you get some compaction, and it just becomes a mess. We don't want to have that happen. Drip systems work better than sprinklers because it's just more focused irrigation on the tree, and specifically focused on the root zone. You apply water slowly to the root zone. This reduces runoff, erosion, and the water loss potential by evaporation. You're just throwing water into the air. Well, some of it's going to hit the ground, and some of it's just going to evaporate off. Here, we're soaking. Everything's getting soaked into the tree. Your emitters, which are the end of the line or inline areas where the water's coming out, should be spread out over the entire root zone, and you want to keep it away from the tree trunk. So you can see here, spread out over the roots, kept away this part right down here. That's what we call the root collar. We don't want to hit the root collar too much. The one thing to really consider, though, is not a lot of competition here, so your root zone is probably farther off than you think. So you really got to look at what your canopy is, and then think about, at least like a couple times that. So you might want to think about, putting that a little bit farther. Other methods: high pressure water injection, soaker hoses, basin irrigation, and temporary portable drip systems. Those are all other methods. The portable drip or soaker systems, the soaker hoses, can be an effective means of supplying water. And actually, soaker hoses are pretty good in terms of irrigation, especially to newly planted or to transplanted trees. And especially helpful during periods of drought as well. You do have problems with irrigation, mostly from just the idea that they're not maintained well, or they're not designed for efficiency or checked for the efficiency. But really, trees aren't really considered in irrigation management programs, more focused on grass and turf. So sometimes you get excessive irrigation, which lead to fungal problems in the root or the collar. Tree root systems are also can be damaged because your irrigation systems are below ground, so your roots could be easily cut when trenched, and you just really want everything to be done right. If you're going to do trenching and these other things, using pneumatic air tools rather than mechanical trenchers, we're going to avoid a lot of problems. We're going to avoid a lot of problems if we really focus on efficiency and effectiveness and what actually works. And if we can, avoid all these problems beforehand, that would be great. But, sometimes you're just going to have to deal with whatever system is there, and you really have to look at it and make sure does this benefit the trees, and if it's not doing it right, what do I need to change?